So today I'm going to be talking about L'Hopital's rule. This is a very important concept in calculus and it helps us evaluate limits. Now before we start talking about L'Hopital's rule, we need to first understand what indeterminate forms are. So for this limit, the first one, if one were to plug in 4 for x, they would end up with a value of 0 over 0, otherwise known as an indeterminate form. For the second limit, one could easily receive a value of infinity over negative infinity, which is just as unworkable. There are many other indeterminate forms in the field of mathematics, but today we'll be focusing on the limits of infinity over infinity and 0 over 0 because L'Hopital's rule can often give us a unique method to solving these limits. Now, L'Hopital's rule is defined as, for any case in which the limit as x approaches a of f of x over g of x equaling 0 over 0, or the limit as x approaches a of f of x over g of x equaling either positive or negative infinity over infinity. For these cases, L'Hopital's rule states that the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of f prime of x over g prime of x. In this way we can solve limits that are otherwise unsolvable, and we can learn more from the numbers that we get out of the limit. Now let's try some example limits. Now for this first limit, we would receive a value of infinity over infinity, meaning that L'Hopital's rule might be a possible method to helping solve this limit and actually get a workable answer. The way we would go about doing this is by doing the derivative of the top and the bottom, resulting in the limit as x approaches infinity of 1 over x over 2x. Now using some simple math, we can rewrite this as the limit as x approaches infinity of 1 over 2x squared. Now, if we were to plug infinity for this limit, instead of receiving infinity over infinity, we would receive 1 over infinity, otherwise known as 0. Now we can actually learn some information from this limit. It's not simply infinity over infinity, an indeterminate form. Now for this next limit, what we're going to want to do is also do L'Hopital's rule, because we would once again receive infinity over infinity if we were simply to plug in for the limit. So let's go ahead and do that. We're going to plug this in and we're going to receive e to the x over 2x. And actually we're not done yet, because once again this would return us infinity over infinity, meaning we're actually going to have to do L'Hopital's rule twice, resulting in the limit as x approaches infinity of e to the x over 2. Now this answer is much more useful to us, because now if we are to plug in infinity, we will receive simply infinity over 2, otherwise known as infinity. In this way, L'Hopital's rule can be very useful in evaluating limits that would otherwise be resultant in indeterminate forms.